Hi everyone. Today let's look at the problem 704, binary search. This is a very easy problem, but good to go through the concept here. This is basically giving us an overview on what binary search is. So now given an array of integers which is sorted, so this is very important, it's sorted in ascending order, and an integer target, write a function to search target in nums. If target exists, then return its index, otherwise return -1. You must write an algorithm with order of log n runtime complexity. So basically this is a search that we need to do in a sorted array, and the expected time complexity is log n. Now let's start with an example here. Okay, I think this is a good example. We can use this. Okay, now let me go through some key concepts here. Okay, now this is our let's put it this way. This is our given array, and assume that we need to find target 9, and let's take these as our indexes for explanation's sake. 4, 5. So these are the indexes we have, and now let's think that in a normal scenario where we just do a linear search, we would start at index 0 and we continue to go through each of these indexes until we find 9. So this will be, in the case of a linear search, this will be of the order of n. So if I put a linear search, this will be having a time complexity of order of n. Here I am not talking about space complexity, because obviously your space complexity will be order of 1. Let's put it there. Okay, now let's try to understand how binary search works. So one important feature that was mentioned in this question was we have a sorted array, and this binary search can be only performed on a sorted array. Now let's try to understand the idea behind binary search. Now basically this involves reducing the search space by half in each step. So how do we achieve that? Let's take a case where we have 2 pointers. Okay, let's put it as low and high. Okay, and let it start at the start and end of the array. We'll find the mid element and see whether the mid element matches our target. So when we tell mid element here, so this has altogether so how do we find the mid element? Mid is nothing but equal to L plus H by 2. Okay, so that means mid element will be 0 plus 5 by 2 here. So it will be 0 plus 5 by 2, which is nothing but 2. So that means we will have a mid here, right? So now we have the mid here. Okay, now what happens is, what we'll do is we'll check whether this element is equal to 9. If we already, so now here since we are searching 9, we will check whether this element is equal to 9. So this is not the case. Now what we will do is we will try to see if 9 is to the left of this mid element or to the right of this mid element. So if now, since the target is greater than this mid element, then that means we can reduce our search space to this elements. So maybe I can repeat once more. So we'll take the mid element, we'll see if the mid element is not the target, then does the target element is the target element to the right of this mid element or to the left of this mid element? Now since it is greater than the mid element, it will lie on the right of this tree. So now we can just reduce our search space to half of this. So what we can do is we can make L plus 1, sorry, L to be mid plus 1. And so now what happens is we will repeat the same process. So now this will become as you can see, to find the mid element, it will be 5 plus this will be 3 plus 5 by 2. So that will get me to 4. So mid will be this one. At this point, mid will be equal to this high L target. So we'll return. Now, if you see here, our algorithm search space is halved in each iteration. So we will have something like n plus n by 2 plus n by 4 and 1. So this will be of the order of log n. So we will have a binary search time complexity which will be order of log n. And of course space complexity is also here. We use some variables, so it will be some constant space. Now let's code this up. Let's take the variable below is equal to 0 int, which will show the leftmost index and the rightmost index in an iteration. So we have nums of size minus 1. We will do the iteration low less than or equal to high. Okay. Now let's find the middle element is equal to low plus. To avoid integer overflow, we can even use this way to find the middle element. Then if nums of mid equal to target, then return. So if the middle element is already the number as shown above, in that iteration, then we can return the mid element, which is the index. If nums of mid is less than target, then that means the target is on the right subarray. So we can just make low is equal to mid plus 1, and else the next condition will be nums of mid greater than target. So then that means the target is on the left subarray to the mid. So that means we can make high is equal to mid minus 1. If we cannot find within this, as long as low doesn't cross over to the high side, then that means the number is not present in the current array. So we could just return minus 1. Now let's just try running this. Looks good. Let's try submitting this. So this also looks good. The same problem. This is the iterative solution actually. Now if you want, we can actually do a recursive solution for this. So what we can do is we can maybe have a private function, okay, which takes, for example, I'll just put binary search helper, okay, and takes in vector int, basically our vector, then int low, int high as arguments. So from here, let's just remove this and let's just make this call with nums comma target comma 0 comma nums dot size minus 1. Basically return it. Okay, and here I think I missed the target, so let me put the target also. Okay, so if low greater than high, that's the exit condition, so we can just tell return -1. Otherwise it is we'll just check if so. First we'll find the mid element. Mid is equal to nums of low plus high minus low by 2. So that would be, as mentioned earlier, to avoid that overflow. Then what we'll do is, if mid equal to nums of mid equal to target, then return mid. If nums of mid less than target, then we have to search the right subarray. So that will be we can just do a binary search helper with the nums target. This will be mid plus 1 comma high. Else we'll just tell return. So the last condition will be the other way around. So this will be low and mid -1. That's it. Let's see. Okay. All right. So that's it for today. Thank you.